So in this video, we will continue our discussion on the lambdas and we will see how a lambda resolves the context. How does it know it can replace the functional interface with the given lambda? There are certain things that it takes into consideration, like method arguments, their data types, constructor arguments and their data types, return type, or variable declaration. So in this example, I have cleaned the code. So we have the functional interface calculator, but in the main method, I have removed all other method calls. We are simply calling the lambda to do the summation. And we will see how a lambda would be able to resolve this thing so that it knows that, okay, it has to call the calculate method of the calculator. So let's start. The biggest hint to the compiler is the method parameter of calculate ops, which is this one. So it knows that when we are calling the calculate ops method, the first argument must be of type calculator. And here when we are calling the calculate ops, the first argument to this method is basically a lambda expression. So the compiler knows, okay, the intent is to execute this lambda expression as a replacement of the calculator interface. So it goes to the calculator interface and it sees that, okay, this is a functional interface. It means there is only a single abstract method. So if this lambda expression is correct, I can replace or I can treat this lambda expression as the implementation of this method for line number 11. Sorry. So moving on, now the task is to see if the method definition matches with the lambda parameters and lambda body. So it knows that there are two method arguments of type integer, and here in the lambda expression on the left hand side, we have two parameters a and b. So that's fine. We have the parentheses. That's also fine. The only thing is we have not given any data type in the lambda parameters. But that's the thing with resolution. Here, the Java compiler knows that the types of these parameters are integer. So that is something that it can infer from the context. It knows that a and b must be of type integer in order to match this definition. So it will assign the type integers automatically under the hood. So we don't have to provide the data types here in the lambda parameters. Now comes the arrow sign, and now we come to the lambda body, which is a plus b. So the compiler checks again that the return type of the method is integer. It means whatever implementation or whatever expression that we are providing, it must return an integer type. And here we see that because a and b are considered to be integers, so the summation of two integers will also be an integer. Now, because there is a single statement, we don't have to mention return. Compiler knows that we have to return the value, so it will do the summation. I mean, the Java runtime will do the summation and it will return the integer value. So overall, it satisfies the method definition that is defined in the functional interface. So we saw that Java compiler was able to infer the data types of method parameters or lambda parameters in this case. It was able to understand that we have to return an integer value even though we did not provide a return keyword. Now, there are other ways also to write a lambda expression, to declare a lambda expression. We know that we have to replace the calculator functional interface with a lambda expression. So what we can do, we can simply say that, for example, we are giving a new implementation for division. So this time, instead of passing the lambda expression directly, we will first of all declare it as a variable. How can we do it? We do it with the use of functional interface because it is supposed to be a replacement of functional interface. So we create a lambda expression as a type of functional interface. So let's do that. We say division And now instead of instantiating the interface, we give a lambda expression on the right hand side. So we know that there will be two parameters, then the arrow sign, and then the body. Now what we can do, we can simply call the calculate ops. We can pass what we declared and two numbers. So we see that there is no compile time error, and again because this time we declared the lambda expression using a calculator type, so it's easier for compiler. It knows that okay, the target type is calculator, and then it applies the same checks: number of parameters, their data type, and the return. So if we run the method, we should see the output of summation and division. So we see the output of division 3, and there is no output for summation because we are just getting the result. We are not doing anything with the result. Okay, moving on. So we said that it knows that it has to return an integer value. So we did not provide a return statement, but can we do that if we want to? So it says that semicolon expected and a curly brace expected. Okay. So when there is a single statement, we can omit all these things. But when we are using multi-statements, or let's say we are returning anything, then we need to change the lambda body. So we place the curly braces, and inside curly braces, we see, let's say, A divided by B. Now this is how we write a lambda with a body that could have multiple statements with curly braces. So here we can say something like going to divide. So if we run the same code again, we see the print statement on the console and the output. So the point is, if we have multiple statements, the only way to write a valid or legal lambda is to provide the curly braces, create a body, and write all the statements within the scope of that body. All right. So that's it on the context. We understood how compiler verifies the method definition, how it validates the lambda expression, how it matches certain things so that it knows it's a perfect replacement. All right. That's it for now. Thank you.